Hello, this is the video for chapter 4, lesson 5. So let's take a look at your notes for today. This is the last lesson of chapter 4. And so after this, you'll be testing over chapter 3 and 4 combined as one test. Okay, looking at today's lesson, it is called scatter plots and trend lines. So before I go into all this vocabulary, because there's a lot today, I'm just going to quickly describe to you what a scatter plot is, with a visual. So a scatter plot is basically where you have a bunch of plots on a graph, and when you connect all those plots, they don't create a straight line. However, normally when we use scatter plots, it's displaying a trend of a relationship. And so that's what we're going to take a look at today. So using the fill in the blanks on your vocabulary, a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. So we've got a bunch of data put in as ordered pairs on your graph. Positive correlation. So positive correlation is a positive correlation occurs between two sets of data when the y tends to increase as the x increases. So both are increasing. The data points tend to go upwards from left to right. So this example here is a positive correlation. A negative correlation occurs between two sets of data when y tends to go downward or decreases. Excuse me. As x continues to increase. So x is still increasing, but the y is decreasing. The data points tend to go downwards from left to right. No correlation is when no correlation occurs between the sets of data when x and y are not related. You're not seeing any sort of relationship between the x and y axis. A trend line. A trend line is a line on a scatter plot drawn near the points. So it's not on top of the points. It's just kind of drawing a line near the points that shows a correlation. We'll look at an example of this in a second. Interpolation is estimating a value between two known values. Extrapolation is predicting the value outside the range of the known values. So interpolation is using maybe that trend line to estimate the values between what you're seeing. Extrapolation is kind of continuing on the graph and predicting the continual trend. Line of best fit. It is the trend line that shows the relationship between two sets of data most accurately. So it's best fit, it's most accurate. Okay, so if none of these words up here really made sense to you, we'll take a look at these graphs below and hopefully the visual will help. So causation, our last word, is when a change in one quantity causes a change in a second quantity. Which another way to see causation is when there's either a positive or a negative correlation. So causation. So one way we can describe causation is when it has a causal relationship. Okay, so let's draw these points. Positive correlation, you have a graph, a scatter plot, where the plots are moving gradually upwards. A negative correlation is as y goes down, x is still increasing. So you can tell with the positive correlation, y is increasing, x is also increasing. No correlation would be where they are just random. There's no way to really tell what type of trend is happening. Let's apply this to a problem that we might see. So it says make a scatter plot of the data in the table below. What type of relationship does a scatter plot show? So we see money and gallons bought for gasoline. And so I would assume the more gas you buy, the more money you have to pay. Let's take a look at what's happening, okay? First, we have to decide what is your independent and dependent variable? What's your X and Y axis? Well, your money will increase if your gas increases, right? So I think gallons bought would be I guess it doesn't really matter. I guess you can put either one, either side, but your gas depends on how much you want to spend. So the gallons we're going to say is Y, gallons or dollars spent will be X. And let's label our graphs. So it's really important to label our graph so we can understand what's going on. On this side, we have gas. On this side, we have dollars. And I'm looking at the range of the amount for my gas. The smallest number that I have is 1.1. The biggest number I have is like 2.8. So I probably don't want to count up by ones on my y-axis per box because or actually the biggest number is 3.3. So if I count up by ones, then I'm only utilizing 1, 2, 3. These first 3 boxes or so of my y-axis. But I'm noticing a lot of decimals. So I might kind of want to space out my information where I'm going from 0 to maybe like 3.5 or something like that, whereas like 3.5 or 3.75 or something like that might be on the top. So I'm going to space out my information so that I'm not utilizing only the first 3 boxes. I want to utilize kind of the boxes to represent decimals as well. So I might go up by quarters. And I'm going to say, I'm going to start with 0.25, and then this would be 0.51, or no, 0.75, sorry, 0.75, and then 1. So every 4 boxes, it's 1. Going up 1, 2, 3, 4. This is 2. Going up 1, 2, 3, 4. This is 3. And I think I'm going to take this 3.5 off because I don't really know exactly if that's accurate or not. So what I'm seeing is I might even just make this a little less crowded. So I've got 1, 2, 3, and then kind of in between the halfway is this is 2.5, In between, this is 1.5. In between 0 and 1, this is 0.5. And then going up, this would be 3.5 gallons. And so gas, and I'm going to write parentheses gallons. And then I'm going to label my dollars, which my dollars, the range of my dollars go up to like $11 or 13, actually $13. So I'm going to count out how many boxes I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so if I go across by ones, I really take up most of my graph. So when you're trying to think how you're going to plot these points and label your graph, you want to think what's the best use of space. If you're only using less than half your graph to plot everything, you're not having the best use of space. Here's 12, here's 13, and then I think that's about my highest. And I'm going to put in parentheses that this is dollars. That should be labeled right next to dollars, but I'm a little crammed on space. Now I'm going to plot my points. So $10 spent for $10, it's 2.5 gallons. So 2 point here, $11, 2.8. So 11, 2.8 is going to be probably a little above 2.75 because in between 2.5 and 3 is 2.75. And then 9, it would be 2.3. Let me go up to 2. Close estimating 2.3 is probably like somewhere here. All right, I'm gonna keep going and let you skip ahead. So I'm gonna plot these points, but I'm gonna pause my side of the video and keep plotting them so you're not watching me plot every single point here. Okay, so as you can see, I've plotted all my points. Hopefully you're doing the same. You can pause the video and plot all the rest of your points. Well, when I'm looking at this, I definitely can tell there's a trend. There's a positive relationship. It's going upward like this. And it's, if I connect all the points, it's not exactly a straight line, but I can kind of create a line of best fit if I wanted to. Let's see if I can create a line of best fit. If I draw a line here, it might go kind of through these points. You can see what I have here. And I might kind of drag this down. So you probably want to get your ruler out to help you with that line of best fit. So if I'm looking at this, I'm trying to find where I could draw my line and it goes through as many points as possible. And so relatively, I think this would be a pretty good line of best fit. I'm going to just extend that, which means yeah, that's my line of best fit. And it's important because in problem 2, it's asking me to draw a trend line in the graph of the above data and write an equation of the trend line. So I have to write an equation for this. And in order for me to write an equation, I really need to identify some points. So I'm going to identify some points that really do mean something on my graph. So I might pick like these 2 points. So I have 5 and 1.3. And maybe this other purple point, which is 8 and 2.2. And I mean, you could pick different points, but you might have some points like this one that doesn't quite trend with most of your other points. So you have some options here. And because everyone's points that they might pick will be a little bit different, your slope might vary a tiny, tiny bit, but it should relatively be similar or in the same range. So I'm going to first work on finding my slope because anytime I have to write an equation for a line, I need to have slope. So step 1, slope, m equals, let's say 2.2 minus 1.3 over 8 minus 5. So 0.9 over 3. I might round this up to like 1 over 3. Who knows? I mean, I don't know if that's worth rounding, but 1 over 3 maybe. And then step 2 is to write your equation. And I'm going to use my point slope form to find the equation. I'm going to basically pick one of my points. So y minus 1.3 equals 1/3 times x minus 5. And then I'm going to utilize my math skills to find the slope intercept form. Okay, so I've kind of worked ahead and jumped through all my work. You can think when you distribute this 1/3 in, you can also rewrite this as a decimal since we do have decimals appearing, which would be 1.6 repeating. And so when I add 1.3 on both sides, I get a negative 0.36. So I'm looking at my trend here for my line of best fit. And it could be that my line goes down a little bit. I mean, it's showing my y-intercept as like negative 0.36. So I guess if I kind of adjust this, I could see how that could work. So you might find a line of best fit and you might work this out and you get a positive, like a positive 0.1 or something. But we know that the y-intercept is relatively close to 0. Mine turned out to be negative as a y-intercept. Yours might turn out to be a positive number if you're using a different set of points to find your trend line. So question here says approximately how many gallons could be bought with $6. This is interpolation, meaning you're looking within your graph. Inter means with inside, right? In. So you're kind of thinking through, let me use a different color here. You're kind of thinking through, let's use orange. Where's 6? 6 is like relatively right here. So that's about like 1.6 maybe or 1.7. So you might estimate it's about 1.6 gallons. Then we have approximately how many gallons could be bought with $15. So you're thinking through your graph and you're like, all right, so if my graph is, we're looking at my 15 here, that's not a part of the plots that I have. It might be, if I continue this, it might be about, $3.75 or, we know it's going to be about above $3.50 or so. So I'm just going to guesstimate, not dollars, about 3.75 gallons maybe with $15. So roughly, it's all guesstimation. Okay, problem 4, we're identifying what type of relationships. Is it like a positive correlation, negative correlation, or no correlation? And then what if the relationships are causal? It's not casual, causal. So is there a cause between, is there a direct relationship when one changes, the other quantity changes as well? So let's read through this. The cost of a family's vacation, the size of their house. Okay, it could, right? The more money you can spend on a vacation, the wealthier you are, because you can only spend money on vacation that's within your means. And if you're more wealthy, you might have a bigger house, which doesn't necessarily mean those are directly connected, right? You could have saved up years and years for a really lavishly nice family vacation and, um, live in a small house. Or it could mean you have a big house because you have a big family, or you have a small house because you have a small family, but you're also really wealthy. So we don't know. This information's too vague, and I don't think there's a direct relationship. However, it could be. It may be positive, but your trend, your graph could be a positive uh, scatter plot, but it those two quantities are not directly related. So it does not reflect a causal relationship. And so I'm not going to write all this down because it takes me too long to write everything down. You're going to say, you know, there could be a positive relationship. However, there's not a positive correlation that reflects a causal relationship. Okay. B, the time spent exercises and the number of calories burned. Okay, that is a very direct. The more you exercise, the more calories burned. There's no question. It can't work the other way. So this is a positive relationship, and it is causal because the more time you spend exercising, the more calories will be burned. That's what you're going to write. Okay, hopefully this wasn't too confusing. But in real life, we tend to have scatter plots because our data doesn't always come out in a perfect line. So scatter plots, honestly, are probably a little more realistic of a type of graph that you would see when you're really, truly collecting data in real life. All right, that's all I have.